Now, let us go back to Apatow's example and consider the two equations again. These two linear equations in the same two variables x and y are called a pair of linear equations in two variables. Algebraically, the general form for a pair of linear equations in two variables can be represented as a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, where a1, b1, c1, a2, b2, c2 are all real numbers and a1 squared plus b1 squared not equal to 0, and a2 squared plus b2 squared not equal to 0. Some examples of such pairs are as follows. 3x plus 2y minus 8 equals 0 and 2x minus 9y plus 7 equals 0. 4x equals y, and minus 7x plus 2y plus 3 equals 0. X minus y equals 8 and 15 equals y. Do you know how these would look on a graph paper? Let us look at the three possibilities we have with each pair of linear equations where each of them represent a straight line. First, the pair of lines will intersect at one point. Second, the pair of lines are parallel, that is, they never intersect. And third, the pair of lines lie superimposed one over the other, that is, they are coincident. Both the algebraic method, as well as the graphical method, can represent the pair of linear equations. Let us see a few more examples. Represent Apatow's situation at Fun Park algebraically and geometrically. Algebraically, the pair of equations formed can be written as: first, y is equal to x by 3. That is x minus 3y equals 0. And second, 4 times x plus 3 times y equal to 60. Geometrically, for plotting each of these equations, we need at least 2 points or solutions. Let us take some random points or solutions for plotting these lines. Here, both the variables need to be positive whole numbers as each represent a count. We can choose a random number value of x, that gives a value of y. Then, we plot the points on an xy graph and connect them in sequence with a line. We can even choose 0 for one variable, to get the other variable. As a general rule of thumb, the idea is to avoid non-terminating decimal number values for ease of plotting. From first equation, y is equal to x by 3, when x is 0, y is 0. When x is 6, y is 2. When x is 9, y is 3. When x is 12, y is 4. When x is 15, y is 5. From second equation, y equal to 60 minus 4 times x by 3. When x is 0, y is 20. When x is 6, y is 12. When x is 9, y is 8. When x is 12, y is 4. When x is 15, y is 0. So, the xy graph for the situation is as shown. It is interesting to note that lines intersect at 12, 4. Please pause the video, rewind and play again to absorb what has been covered in the topic. Let us proceed now.